In the last video, I walked through creating a task class, which I'll be using in this challenge. In addition, I created a task data class to return 4 different sets of data, which will also be used in this video. If you decided not to watch the last video and build that code, you can find it as a download in the resources section of this video. This class diagram shows you the 2 classes. Task has 5 fields, 2 with enum types as shown. Task is unique by the project and description fields combined. Task implements comparable and is sorted by project then description. Some test data was set up on the task data class, and you can get this data by calling taskdata.getTasks, passing it the names Anne, Bob or Carol, or any other string, like all, to get all tasks. If you didn't watch the last video, take a minute to get familiar with the data set up as 4 text blocks on the task data class. In addition to this code, I included a couple of methods on the main class to print sorted collections with a descriptive header. One takes a comparator of your choice, the other doesn't, meaning the elements will get sorted by the comparable sort. Let's say that you're a new manager of a team that consists of 3 team members working under you, Anne, Bob, and Carol. Each of these developers is working on a set of tasks. The management of the tasks has been a manual process, and you don't really have a good way of knowing who's working on what, how things are prioritised, or how evenly the work is distributed. You've asked your developers to submit what they're working on to you. You also have a master set of tasks which your boss sent to you. I've included this data in a CSV file in the resources section of this video, and it's built into the task data class. You'll be using that data to answer the following questions. What is the full task list? This is the list of all tasks described by your manager and any additional tasks the employees have that may not be on that list. Which tasks are assigned to at least one of your 3 team members? Which tasks still need to be assigned? Which tasks are assigned to multiple employees? To do some of this work, create 3 methods on your main class. Be sure the sets you pass to these methods don't mutate in these methods, in other words, return a new set. Create a getUnion method that takes a list of sets and will return the union of all the sets. Create a getIntersect method that takes 2 sets and returns the intersection of the sets. Create a getDifference method that takes 2 sets and removes the second argument set from the first. Okay, so give that a try now. If you get stuck, or when you have completed the challenge and want to see how I went about coding this, then come back and I'll walk you through my solution. Pause the video now. Welcome back. How'd you do? I've got my Set Operations Challenge project on the screen here, and you can see where I left off in the last video. I've set up a local variable called tasks, which I retrieved from the taskdata.getTasks method, passing that the literal string all. This set of tasks represents the tasks our manager remembered or thought they knew about. As with most data, it might contain some mistakes, meaning it might have tasks that haven't been assigned, or it might be missing tasks altogether. I've executed the sort and print method, passing the literal string all tasks and the tasks set to it. In addition, I got Anne's task in much the same way, calling getTasks but passing it the name Anne there. In this case, I'm printing the set with an overloaded version of sort and print that takes a comparator. I've created a local variable, comparator, that uses comparators methods to create one that will sort by the task's priority field. If I run this code now, I get the boss's list sorted by project and description. I also get Anne's self-reported list sorted by priority. The challenge suggested I create 3 methods on this class, so I'm going to do that before I do anything else. I'll make these all private and static, and all will return a set with a type argument of task. The first will be named getUnion, and that's going to take a list. The list type argument is going to be a set of tasks. That looks a bit ugly, but it allows us to pass more than just 2 sets to this method. It effectively lets us pass a variable number of sets. So why didn't I just use a variable argument with sets of tasks? Let's see what happens if I do that. I'll change my argument to be a variable arguments declaration with set type argument task as the type, 3 colons, and IntelliJ has a warning for me. If I hover over that, I see a message, possible heat pollution from parameterized var arg type. That's an ominous message. Possible heat pollution doesn't sound too good. I didn't discuss this in my generics videos because it's a somewhat advanced topic, and I'll be covering it when we get to annotations. As you can see, I can annotate this method. I promised not to cover new material in challenges, so I'm going to undo this change. I'll come back to this and other complicated generics issues at the appropriate time in a context where it makes sense to introduce them. Here, I'll use a list of sets as my argument. Next, I'll set up a local variable, a new hash set. Remember that I don't want to mutate any of the sets passed as arguments when I execute this operation. I'll loop through the list of sets. I'll execute add all on my local variable set, passing at each set in the list. Finally, I'll return this new set, which is the union of all the sets in the list. Since sets won't include duplicate values, this method will give me a distinct collection of all tasks from all the sets passed. The next method is getIntersect. You can do an intersect on more than 2 sets, but for the questions I need to answer for this challenge, I'm more interested in comparing only 2 sets at a time. This method is called getIntersect, and I'll have sets A and B. I'll again create a new set. This time I'll initialize it with set A. To do an intersect, I use the retaiNall method. It's important to call this method on the local variable and not the method argument set itself. This is so I don't mutate the sets passed to this method. I'll return my local variable, the result of an intersect operation on 2 sets. The last method is getDifference, and that will also have sets A and B, both sets, with task as the type argument. I'll yet again create a local variable, a new set, assigning that a new hash set instance, and again pass it the first set, set A. I used removeAll, importantly on the result variable, passing it the second set, B. This does an asymmetric set difference, subtracting B's elements from A's. I return the local variable result. These methods will make the next bit of code a bit clearer. This is the code to answer the 4 questions on the challenge side. First, what is the full task list? How would you go about getting that? If it was a perfect world, it would just be tasks, the list we got from our boss. But never assume anything is perfect or right. Trust but verify. To do this, I probably want a union of all 4 sets, the boss's tasks and each of the team members' tasks. First, I'll get Bob and Carol's tasks. I'll do this in the main method at the end there. I'll create a local variable first for Bob's tasks and assign it the result of task data.getTasks, passing Bob in quotes. I'll do the same for Carol, so Carol's tasks, and I'll pass Carol in quotes to that method. Then I'll create a list of these sets. I'm going to create a union of these 3 sets. That union is going to be useful in answering several questions. I'll set up a new local variable, a set of tasks, calling it assignedTasks. I'll assign that the result of calling my getUnion method on my list of sets, which is the list of Anne's, Bob's and Carol's tasks. I'll print these assigned tasks in natural sorted order. Running this code now. That gives me the answer to the second question, which tasks have been assigned to a team member. To answer the first question, I could include the full tasks in the list I passed to my getUnion method. In fact, let me do that. I'll set up another local variable, a set, called every task, and call getUnion with a list of 2 sets, tasks, the boss's set, and assigned tasks, the union of tasks all my team members claim to be assigned to. And I'll print that. I'm going to call this the true all tasks. I'll test this out. The result is a list of a lot of tasks. I could try to eyeball that list with the boss's set, but I don't have to. I can use a set operation to give me what's missing from the boss's list. I'll set up a local variable, a set, missing tasks, and now I'm going to call my getDifference method, passing it every task set, and the boss's set called tasks. And I'll print that out with the header missing tasks. Running that now to see what we get. I get 2 tasks that weren't on the boss's radar, but are assigned to Anne. Okay, so that answers the first 2 questions of the challenge. The next question is to figure out which tasks haven't been assigned to anyone. Do you know how you'd go about doing that? Did you guess the difference between the boss's set and the union we created of all the team members' tasks? That's one way to do it, and the way I'll code it now. I want a set variable called unassignedTasks, and that's going to be assigned to the result of a call to getDifference, passing first the tasks the boss says needs to get done, and then the union of all the tasks my teammates say they're working on, the assigned tasks set. This time I want to print these unassigned tasks, not by the default sort, but in priority order. Running that code now. I can see the tasks that aren't yet assigned. Included in this is a high priority task, so I need to figure out who to give this to. Before I do that, I have to understand if there's been any overlap. Do I have different team members assigned to the same task? In real-world development teams, this is probably a valid use case, but in my case, my task should be assigned to only one team member at a time. If I did an intersect of all my team members' tasks, would this be the right answer? What do you think? No. That would only answer the question, which task is assigned to all three team members? That's not the question I need to answer. To answer my question, which tasks are assigned to different team members, I'm going to do a series of intersects. I'll intersect each combination of two team members, so I'll first intersect Anne and Bob, then Bob and Carol's tasks, and finally Anne and Carol's. Remember, intersects are asymmetric, so luckily I don't have to do the operations in reverse like Bob to Carol. After I get this information, I want to union these three results, and this will give me a set of all tasks where there's overlap. Let me implement this now. Instead of setting up a bunch of local variables, I'll nest the calls, each call to get intersect, directly inside a getUnion invocation and inside of a list creation method. I'll set up one variable, a set named overlap, and assign that the result of getUnion, which I'm going to pass a call to list.of. My first set is the intersection of Anne's tasks and Bob's tasks, coming back from the getIntersect method. My second set is Carol's tasks intersected with Bob's tasks. The last intersected set is Anne's tasks and Carol's tasks. Finally, I'll print these, sorting by priority. Running this code now to see what we get. I discover that 4 of my tasks are assigned to multiple team members. Note that name here represents only the first person assigned to the task. Interestingly enough, it looks like Anne is assigned to all the duplicate tasks. If Anne were a manager or an intern, that might be okay, but she's not. I'd like to get a bit more information about these duplicates or overlaps. Because I don't want to remove duplicates, I'll set up another variable, a list of tasks, and call that overlapping a new array list. I'll loop through each team member's set of tasks, and now I'll set up a local variable called dupes, assigning that the result of getIntersect, passing it the full set of tasks and overlap. This will give me the task assigned to this team member that's also assigned to somebody else. I'll then add to my overlapping list. Now I want to print this out, but I want another sort that's first by priority, but then sorted in the natural order within priority. I'll set up another comparator variable and call that priority natural and assign that the sort by priority comparator, but chain the then comparing method, passing it comparator.naturalOrder. This will sort by priority, then project, then description. Since my sort and print method takes a collection, I can use it to print lists too, so I'll call it passing my overlapping list and my new priority natural comparator. Running this code, I get returned a list of tasks that I'll most likely need to reassign. Anne and Bob, my strongest team members, are assigned to the same tickets in all of these cases. Carol, a new member, has some overlapping tickets, but she hasn't started any. Okay, so this code answered all the challenge questions, and I hope you had some fun with this. I like set operations probably because I like to look at data from many angles. Moving on now, I want to next talk about other implementations of the set interface. I'll see you in the next video.